Okay, so yesterday we started Chapter 4, Section 2's notes. Today we're going to continue graphing the rational functions. So I'm going to go ahead and start with example 4. So again, the first thing I'm going to do is look for my horizontal asymptote. And remember, to do that, we look at the degrees of both the numerator and the denominator. So just to recap, remember when the degrees, so if you have it like this with a, let's say it's x to the m or x to the n over x to the m. So when the degree, when n and m are equal, the horizontal asymptote is going to just be y equals the leading coefficient. When the degree is going to be smaller on the top, so top is smaller, that's when you need to memorize that the horizontal asymptote is y equals 0. And then when the top is bigger, on the quiz and in the homework, you're going to tell me that there is no horizontal asymptote. So you would say none. And then the one scenario when the top is 1 bigger, that's when we're going to have a slant asymptote. And you do long division to find it. So these are the 3 scenarios or 4 scenarios that you need to memorize for the horizontal. Remember, the vertical asymptote, all we're going to do is set the denominator equal to 0. But what we're setting to 0 is the simplified function. So let's go ahead and do the first one. So for the horizontal, we don't need to simplify. We're going to look at the degrees. Notice both of these degrees are the same. So I'm going to use my leading coefficients, which is 1 over 1. So my horizontal asymptote is just going to be y equals 1. So I can go ahead now, and I'll go ahead and graph that in red. So my horizontal asymptote is this horizontal line through the y-axis at 1. For my vertical asymptote, I'm setting the denominator equal to the simplified function, the denominator equal to 0. So the first thing I need to do is simplify this. So I can factor it and look for factors to cancel. The numerator is going to be simplified into, this is the difference of 2 squares. So x plus 3, x minus 3. And then the bottom, that trinomial will factor into x plus 1 and x minus 3. Notice what we'll simplify here is the x minus 3's cancel. This is also indicating that I'm going to have a hole in my graph. But I'm going to finish finding the vertical asymptote first, and then I'm going to find the hole. Now, when you're keying this one in, when it simplifies, and you want to see what the graph looks like, do not key in the simplified function. Always key in the original to your calculator. So now this is my simplified function. G of x is equal to x plus 3 over x plus 1. So to find the vertical asymptote, I set the denominator equal to 0. And my vertical asymptote is located at x equals -1. So I'll go ahead and draw that asymptote in here. It's the vertical line through -1 on the x-axis. Now let me go ahead and calculate my hole. So I actually have a hole here. And it's located at the factor that was canceled. So x minus 3 equals 0. Add 3. This is the x of my order pair. And now to get the y, I take the simplified function, x plus 3 over x plus 1, and I'm going to replace x with a 3. So this simplifies, and I get 3 plus 3 over 3 plus 1 which gives me 4. 6 over 4, which simplifies 3 to 2. So my whole is located at 3 comma 3 over 2, which is really, for graphing purposes, 1.5. So let me go ahead and put the whole in the graph. So at this order pair, I come over here to 1, 2, 3, and then 1.5, and I'm going to put an open circle. This is my whole in the graph. Next, I need to calculate my intercepts. Now, in your calculator, whenever you're looking at the table of values, whenever there's a whole and wherever there's an asymptote, you're going to see error, the word error. So if you look at the order pair where the x value is 3, under the y column, it has the word error. Same thing's going to happen on my x-axis there. My vertical asymptote and my horizontal, it should say error in your calculator, okay? So don't think there's something wrong. So let's go ahead and find the intercepts. Let's do the y-intercept first. Remember, to find the y-intercept, you set x equal to 0. And I can go ahead and plug this into the simplified function. So y equals, and the simplified function was the x plus 3 over x plus 1. So 0 plus 3, 0 plus 1, 3 over 1, y equals 3. So 0 comma 3 is going to be my y-intercept. So I can go ahead and plot that point as well. So there's my y-intercept. Now I have to find the x-intercept. Now remember, for the x-intercept, really what we're doing is we're setting y equal to 0. But remember, the shortcut is just to set the numerator equal to 0, because that's essentially what we're doing when we plug in the 0. So my simplified is going to be y equals the x plus 3, or 0 equals, sorry. 0 equals the x plus 3, which is the numerator, minus 3, x equals negative 3. So my x-intercept is negative 3 comma 0. So let me go ahead and plot that one as well. Now, what you're going to do to get your additional points is key in the original function into your calculator, and then you're going to use the second button and then the graph button to get the additional order pairs. Now, I want you to list the additional order pairs in your homework and on the quiz. I want to see at least 2 additional points to the left of the vertical asymptote and 2 from the right. More is better, but a minimum of 2 additional points in addition to any intercepts that are there as well. Everybody understand that? So let me go ahead and key this into my calculator. We need to add in some additional points to the left of the blue line. So my intercept is at, or my vertical asymptote is at negative 1. So I need to find some numbers that are less than negative 1. So I could get negative 2 from my graph, and I could plot negative 2, negative 1. Another point that I could graph could be negative 5, and it's a half. So I could plot those to the left of the vertical asymptote, and then to get points to the right of it, let me go ahead and get some other points. I could plot 1, 2, and I want you to list these in the homework. Another point that I could graph could be 4, and it's 1.4. So let me graph these, and then we'll go ahead and see these boomerang shapes. So negative 2 and positive 1. So again, it's going to be looking So it's going to go like this. And then here, do not make the graph go through the hole. So you see how I stopped it on either side of the hole. So these additional points are going to tell you where these boomerang shapes are going to be in relation to your horizontal and your vertical asymptote. Now, we also have to list the domain and the range. So the domain for number 4, this one is going to be all real numbers except when x equals -1 and when x equals 3. So to find the restriction on the domain, you need to go back to the original, not the simplified. Because remember, we had a hole at 3 and we have an asymptote at -1. So this one in interval notation is -infinity to -1, union -1 to 3, union 3 to infinity. All right, so this is number 5. And again, we're just doing the same stuff over and over again. I'm going to go ahead and look for my horizontal asymptote. So I'm going to look at the degrees. The degree of the top is 2. Degree of the bottom is 1. The top is bigger. So horizontal asymptote, you would list none. This one has a slant asymptote. And in order to find the slant asymptote, we need to do long division. So I'm taking the numerator, x squared minus x minus 0. I'm going to hold the place, divided by the x plus 1. What do we multiply x by to make it x squared? We multiply it by x. We distribute. We switch the signs to opposite and add up the columns. I get -2x, bring down the plus 0. What do we multiply x by to make it 2x? -2x is -2. This was a positive 0, so I bring it down. Multiply -2x minus 2, flip the signs to opposite. I get a remainder of 2. For the slant, we do not use the remainder, so my equation for my slant asymptote this time is y equals that quotient, x minus 2. I'm going to go ahead and graph this one in purple. Now, this is in the form b. Y equals mx plus b. So my beginning point starts on -2. My slope is 1. So I'm going to rise 1 and run 1. So I start at -2 on the y-axis. And I'm going to rise 1, run 1. And you could keep repeating it if you want to get a nice, precise slant line. Now I'm going to find the vertical asymptote. Remember, we need to simplify the function first if it can be simplified. So if I take my g of x and I factor that numerator, it'll factor into x times x minus 1 over x plus 1. Nothing simplifies here. So my vertical asymptote is just found by setting the denominator equal to 0. So I have a vertical asymptote at -1. X equals -1. So I'm going to go ahead and graph that one as well. And now I need to find my intercepts. So this is my vertical asymptote. So for my y-intercept, remember you set x equal to 0. So y equals 0 times, I could do it in the original. Let me do it in the original, it might be easier. Or into the factored one, it doesn't really matter. 0 squared minus 0, 0 plus 1. I end up with 0 over 1. Whenever the 0 is in the numerator, this simplifies to 0. So my y-intercept is 0, 0. So I can put a point there at 0, 0. Now I need to find my x-intercept. And for my x-intercept, remember the shortcut is setting the numerator equal to 0. So I'm going to take my factored numerator from right here, set each of the factors equal to 0, add 1. So I have two x-intercepts. I have one at 0, 0, and I also have another one at 1, 0. So these are my x-intercepts. So 1, 0 is the other one. Now I need to get the additional points from my calculator. So let me go ahead and enter the original function into my calculator. Order pairs. Oh, I forgot to do domain on the other one. Let me go back and do that. So additional ordered pairs on this one, I could do -2, -6. I also need another one less than -1. I could do -3, -6. And then to the other side, I could do 2 and then 2/3. I could do 3 and 1.5. The more you put on here, the more precise your graph is going to be. So I could go ahead and zoom in. I want to see at least 2 for each boomerang. You know, 3 is better, but at least 2. Okay, so let me go ahead and add in these boomerangs. So if I graph these order pairs, 2 and then the 2/3, which would be about here. So it's going to go like this. It's actually going to dip down a little bit and then skim along the asymptotes. And then this one I had -2, -6. So then this one is going to be skimming along here. Oops, I missed it. So then it'll skim along here. So just list the order pairs, the additional ones. Now, the domain of this one is going to be all real numbers except when x equals -1. So the domain in words, but you're going to list it in interval notation. So this one's all real numbers except when x equals -1. And interval notation, and this is how I want to see it on the quiz, from -infinity up to -1, union with -1 to infinity. Let me go back and give you the domain for number 4. All right, number 6. Again, we're looking at the degrees. Degree of 2, degree of 1. My horizontal asymptote is none because the top is bigger. But because it's 1 bigger, I have a slant. So I'm going to do long division. So for the slant, we're going to put the numerator in the division box and the denominator outside. So what do we multiply x by to make it x squared? We will multiply it by x. Distribute. Flip the signs to opposite. Add the column. I get 0 on both of these. And when I bring down the -2, I can't figure out what to multiply x by to make it -2. So this -2 is just my remainder, and I get rid of it. So my slant asymptote is just y equals x. And again, this is y equals mx plus b. Notice there's no b. So my b, my starting point is 0. And my slope is 1. So I'm going to rise 1 and run 1, starting at 0. So I start here at 0, 0. Rise 1, run 1. And I'll make my slant asymptote here. This is also called an oblique asymptote, if you ever see that terminology on a standardized test. But on the quiz, it's going to ask for a slant asymptote. So this is the slant. Next, I need to look for the vertical asymptote. But again, in order to find the vertical or the VA, I need to try to simplify my function first. So g of x is equal to, and then I can factor that numerator. It's going to factor into x minus 2 and x plus 1. But even factoring it doesn't get anything to simplify. So for my vertical, just set that denominator equal to 0. And my vertical asymptote is located at x equals 1. So I'll go ahead and draw that in there. Next thing I need to find are my intercepts. Y-intercept, set x equal to 0. So y equals 0 squared minus 0 minus 2 over 0 minus 1 gives me negative 2 over negative 1, which simplifies to positive 2. So my y-intercept is the order pair 0, 2. So I can put a point there. Now we'll find the x-intercept. And again, the shortcut is just setting the numerator equal to 0. So it was x squared minus x minus 2. I need to factor it. Set each of the factors equal to 0. Add 2. Over here, subtract 1. So I have an x-intercept at 2, 0, and then at negative 1, 0. These are my two x-intercepts. Let me go ahead and plot those as well. So negative 1 and 2. Now what I need to do is find the additional points from my calculator. So I'll go ahead and key this in. So I need some additional order pairs to the left of my asymptote. So I need to find something. So I could use negative 3 and negative 2.5 would be a good one. A lot of these are crazy decimals, and that's fine. You're just going to approximate the location when you go to graph it. So these would be 2 that are to the left, and then I can also pick 2 to the right of positive 1, which is the x value. So I could also graph 3, 2 and 5, 4.5. So these would be my additional points that I'm putting on my graph. So if I graph these, notice it's skimming along the slant asymptote and the vertical, and then the same thing here. It's going to skim along the blue line and the purple line. The domain here in words is going to be all real numbers except when x equals 1, and then in interval negative infinity to 1 union 1 to infinity. And then we have one last example. Example 7. Again, let's look at the degrees. The degree of the top is 2. Degree of the bottom is 1. So this tells me no horizontal. So you'd say none. It has a slant because it's 1 bigger. So we have to divide. And remember, we need to hold the place of that missing x term. So I'm going to put a 0x in the middle there. And I'm dividing it by x. So what do we multiply x by to make it 3x squared? We'll multiply it by 3x. We'll multiply, change the sign. We bring down the 0x. There's nothing I can multiply x by to make it a 0x except for 0. So this is my slant. So my slant is going to be y equals 3x. Because this would be my remainder once I bring this down. and I can't do anything with it. So again, this is in y equals mx plus b form. Again, there's no b, so you start at 0, 0. This is the slope, so 3 over 1, rise 3, run 1. So here at 0, 0, go up 3 and over 1. You can keep repeating it if you want, and then connect your points. And there's your slant. Now let's go back and look for the vertical. Notice nothing simplifies here. So my vertical asymptote is just going to be setting the denominator equal to 0. So my vertical asymptote is just the y-axis. It's just x equals 0. Now, this is one where you'd want to change the table. You probably want to see some x values going by decimals. You don't want to see them going by whole numbers because it's going to be kind of hard to see where the boomerang is. So for example, I've already keyed it in, or let me find my intercepts first. Notice both of them are going to be none. Let me go ahead and do it though. My y-intercept here, I'm going to be going ahead and setting x equal to 0. So y equals 3 times 0 squared plus 1 over 0. I get 1 over 0. Can't have a 0 in the bottom. This is undefined. So there is no y-intercept. I'm going to do the same thing. I am going to go ahead and set my numerator equal to 0 because that's the shortcut for the x-intercept. So 3x squared plus 1 equals 0. Soon as you start this process, and you can see that you're going to be solving for an x squared, and x squared is equal to a negative number. This is a clue when you square root it, we're going to be getting an I. So this is also no x-intercepts. Now, just a little bit of preview of what we're going to do tomorrow. Whenever you get something like this and it asks for an x-intercept and it's an I, you would say none. But if it asks you to list the zeros, you will list the imaginary as a 0. So when we review the polynomials tomorrow, you need to know the difference. And we're going to talk about it tomorrow. But for this homework, there is no x-intercept here because it's imaginary. So now what I need to do is get the additional order pairs from my calculator. So let me go ahead. I've already keyed it in. Let me show you what my calculator looks like. So my additional points could be, I could graph the order pair 1, 4, 2, 6.5. Then I also have to get some negatives here, or something less than 1. Like, I actually have 1/4 on my calculator and 4 3/4. I could get -1 and -4. That would be another additional point. I could do -2 and -6.5. So let me go ahead and show you where these are going to be located. So if we come over here, -1, 1, 2, 3, 4, it's going to be located squeezed in down here. And then the other way up here, 0.25 and 4.75. Let's see, 1, 2, 3, 4. So like it's starting here and it'll be in here. So more than likely, you might get something similar to this question on the quiz where these boomerang shapes aren't going to touch the axis, but they may be way up here. So you're going to need to be able to manipulate your calculator and use the window to zoom in and out. Now, if you look at, let me go ahead and do the domain here. And the domain here is going to be all real numbers except when x equals 0. So an interval, which is what you're going to do on the quiz, negative infinity to 0, and 0 to infinity.